But what happens when the snow doesn't just fall? It buries everything. I'm talking about places where winter isn't just a season. It's a battle for survival. Imagine regions where snowfall is measured not in inches, but in feet, overnight. In some parts of the world, like Siberia or the Arctic Circle, temperatures can plummet to unimaginable lows, dropping to -50, -60, or even an insane -70 degrees Celsius. At these temperatures, normal life grinds to a halt, roads disappear, homes are cut off, and emergency services can't get through. It's a logistical nightmare. Standard snowplows and blowers, they just can't cut it. Their metal becomes brittle and shatters like glass. Their engine seize up, lubricants turn into solid wax, and hydraulic systems freeze solid. The challenge isn't just about moving massive amounts of snow. It's about building machines that can even function in such an extreme, hostile environment. This is where engineering meets the raw power of nature. We're venturing into a world where failure isn't an option, and the only way to win is to build something tougher than winter itself. So, how do you design a machine that can conquer the coldest places on Earth? That's the billion-dollar question we're going to answer today. The first major hurdle is the materials. Normal steel, the kind used in your car or a typical construction vehicle, undergoes a process called ductile to brittle transition at low temperatures. In simple terms, it loses its ability to bend and flex, becoming incredibly fragile. A small impact that would normally just cause a dent can shatter the entire structure. So, engineers have to turn to specialized alloys. We're talking about high-grade steel mixed with elements like nickel, which helps maintain ductility even when it's colder than a freezer. These aren't your off-the-shelf materials. They're custom formulated and incredibly expensive, but they are absolutely essential for the frame, the plow blade, and any other structural component that will face the brutal cold. But it's not just about the frame. Think about every single part of the machine. The rubber in the tires or tracks would normally become as hard as a rock and crack apart. So, we need special synthetic rubber compounds, formulated to stay flexible and maintain grip even at -70 degrees. Every bolt, every wire, every hose has to be re-engineered for this environment. It's a meticulous process where every component is tested to its breaking point in cryogenic chambers before it ever sees a flake of snow. The goal is to create a machine that doesn't just survive the cold but thrives in it. Now let's talk about what makes these beasts move, the engine and the fluids. A standard diesel engine would be a frozen block of metal in these conditions. Diesel fuel itself starts to gel or crystallize around -15 Celsius, clogging fuel lines and filters completely. To combat this, these extreme machines use a combination of solutions. First, they use special Arctic-grade fuel, which is formulated to resist gelling down to much lower temperatures. But even that isn't enough. The real secret lies in a sophisticated preheating system. Before the engine is even turned over, a network of electric or diesel-powered heaters kicks in. These heaters warm up the engine block, the oil pan, the transmission, and even the battery. Think of it like giving the machine a warm blanket before asking it to go out into the cold. The hydraulic fluid, which powers the plows and augers, is also a special synthetic blend with an extremely low freezing point. And even then, it's circulated through a heating system to ensure it stays fluid and responsive. Without these preheating and fluid management systems, the most powerful engine in the world would be nothing more than a 1,000-pound ice cube. It's this smart internal heating that keeps the machine's heart beating in the deep freeze. So we have a machine made of super strong materials and an engine that can actually start. But how does it tackle a snowdrift that's 10 or 20 feet high? This is where raw power and intelligent design come together. These aren't just snowplows, they're rotary snowblowers on a monstrous scale. At the front, you'll find massive serrated augers like giant corkscrews made from that same high-strength, brittle-resistant steel. These augers chew through compacted snow and solid ice, breaking it up and feeding it into a high-speed impeller. This impeller, spinning at thousands of RPMs, acts like a giant fan. It launches the snow through a chute, throwing it hundreds of feet away from the road. The key is to get the snow far away, so it doesn't just create a new, even taller wall right next to the cleared path. The operator, sitting in a heated and pressurized cabin, can control the direction and angle of this chute with joystick precision, strategically placing the snow where it won't cause more problems. Some of the most advanced models even use GPS and LiDAR to map the terrain, allowing the operator to work with incredible accuracy, even in a complete whiteout. It's not just brute force, it's a carefully orchestrated process of destruction and relocation. Operating one of these machines is unlike driving anything else on the planet. The cabins are more like cockpits than truck cabs. They are fully insulated, often with double or even triple paned heated glass to prevent fogging and frosting. The air inside is pressurized to keep the operator's environment stable and comfortable, even when the world outside is an Arctic hellscape. Visibility is a huge issue, so these machines are covered in high-intensity LED lights that can cut through blowing snow. They also have an array of cameras providing a 360-degree view around the vehicle, displayed on multiple screens inside the cab. The operator is a highly skilled professional. They're not just driving, they're managing multiple complex systems at once. They're monitoring engine temperature, hydraulic pressure, auger speed, and impeller load, all while navigating treacherous, invisible terrain. They use the GPS and LiDAR data to see where the road is supposed to be under all that snow. A single mistake could mean getting the multi-million-dollar machine stuck, or worse, causing a catastrophic failure. These operators train for years in simulators and then in less extreme conditions before they ever let loose on a minus 70-degree challenge. They are the unsung heroes who keep the lifelines of these frozen communities open. So what's the future for these incredible machines? As our climate continues to change, we're seeing more extreme weather events, including unprecedented snowfalls in regions that weren't previously prepared for them. The technology developed for these minus 70-degree monsters is starting to trickle down to more conventional snow removal equipment. We're seeing more efficient engines, smarter hydraulic systems, and better materials being used in the snowplows that clear our own city streets. Furthermore, automation is the next frontier. Imagine a fleet of these machines operating autonomously, guided by satellite and ground-penetrating radar, working 24/7 to keep critical infrastructure open without risking a human operator. The principles learned from building these machines are also being applied in other extreme environments, from deep-sea exploration to space rovers designed for the frozen moons of Jupiter. The challenge of conquering extreme cold on Earth is pushing the boundaries of engineering, creating technology that will not only help us survive the harshest winters but also explore new worlds. It all starts with the simple, yet profound problem of needing to clear a path through the snow. Building a machine to work at minus 70 Celsius is a testament to human ingenuity. It's a story about refusing to be beaten by nature and instead learning to work within its most extreme rules. From custom metal alloys and synthetic fluids to advanced GPS guidance and heated cockpits, every piece of these machines is a solution to a problem that would seem impossible to most. They are the guardians of the North, the titans of winter, ensuring that, even in the coldest, darkest corners of the globe, life can go on. Thank you so much for watching. If you found this journey into extreme engineering as fascinating as I did, don't forget to hit that like button and subscribe for more deep dives into incredible technology. Let me know in the comments what other extreme machines you'd like to see us cover. Stay curious, and we'll see you in the next one.